Hello everyone. How is it going? Cool? Are you inspired? Yes. Okay. So thank you for coming for this talk. And I hope it will be useful for you. And today we will be talking about a simple theme. And I would like to say that I am neither an industrial nor academic Haskeller, because the talk will be pretty much simple. So I believe I kind of kindergarten Haskeller, and I hope it will be understandable for all of you. If not, it's okay. There is a philosophical context there, so we will talk about social things as well, not about only technical things. Okay? Do you hear me well? Yes. Okay. So let's start. First of all, let present me a plan of this talk. We will be talking about free monads, a little bit how to structure business logic. Then we will see how to write tests for your free monadic business logic. After that, we will dive into the automatic white box testing, the technology we are using in JustPay. And essentially, it was invented for JustPay, and it was happened due to our work in JustPay. And this technology helps us to keep our code protected from changes. And maybe we can talk about more about this industrial application of this technology after the talk. Still, let's start from the my presentation. Who I am. I'm a Haskeller software architect. I am now calling myself like this because I'm writing a book, Functional Design and Architecture, and all these ideas I base it on this book and what I'm describing there. I also used to work in many different companies as a Haskeller, currently working for JustPay. And in all of these companies, we used free monads, for example, for our needs. There is a white background. In my past work, I'm former C++ developer, but now switched to Haskell and feel fine. And yeah, I'm visiting different conferences to speak about my ideas, to spread these ideas, because you know, in the Haskell community, we need more stuff about software design. And you probably heard that there is a drama in our community that is called fancy boring dichotomy, and it seems like we have two different sub-communities. That one who is arguing for fancy Haskell are very smart guys, and they do cool libraries. And there is an opposite movement that is called boring Haskell, which states that we have to write the simplest possible code so we could understand it easily and reduce risks. It's up to you what side to choose, but I would encourage you to choose neither that nor this, because there is a safer way that doesn't require from us to kill all these projects by our decisions, and this way is called software design. Okay? And in here, I'll talk about software design in Haskell a little bit. And I'll use free monads mostly. And the first part of my talk is about how to write business logic using free monads. Are there any people who used free monads lately? Okay, so maybe effect systems, and final tagless. Not so much actually, not so many. It's okay. Nevertheless, we will consider a simple scenario that can happen in any company because it interacts with database. Firstly, we will connect to the database. Then we query some things about students, like query all the students and query expelled students. Strange queries, I agree. Then we have some lists of results. After that, we can subtract one list from another, and we will get the students who is active in this university. And the final thing, we want to print this information somewhere, maybe to console. It's a simple scenario, right? But it can show us the idea. And this is how it looks like in Haskell, written on the free monadic framework, which is called Flow. And by the way, all this code is available in the showcase, which supports this talk. You can play with it. And you see here the connection string, like we get some connection to the database. Then we evaluate some queries to the database. And we can log some info to the logger, or maybe console, or maybe whatever you want. And then in here you see some logic. Do you see something wrong here? Excuse me?
Sorry.
Can you repeat, please?
Sorry, we say here sign.
Sign. It should be minus, right? To get not all the students, but those who is active, not expelled from the university, but who is active.
In second when condition, I suppose it should be count not equal 0.
Yeah, probably. Okay, yeah, there is bugs here, right. And how would you test this code? Would you? Do you write tests? Who writes tests? Okay. People who didn't raise hand, why not? Production. Okay, you are industrial people and you don't write tests. Okay, I understand that. Okay, let's move further and see what we can do here, because essentially there are two bugs here, right? But first we will see how the internal flow framework is built. Essentially it's a algebraic data type that has several methods like connect, run_db, etc. And it's a free monadic type. I defined here flow. And this is almost all you want to know about the underlying interfaces, because there are no any implementation details here. Only a business logic, which could know only on these things and nothing more. For example, you don't know what logger is used here. Maybe it's catip, maybe it's calllog, whatever. It's just an interface, an analog of OOP interface to your subsystems. And what's interesting here is that the free monadic language can be nested one into another, and you will get hierarchical free monads. It's our approach we use in JustPay, and I developed for my book, and it simplifies the business logic and allows us to do some stuff. For example, here we have an internal free monadic language database with one method only, but it's not the case for production. There will be a lot of methods there probably, and you can do this for all your internal effects as you wish. And to know more about this approach, I encourage you to check out my talk from Bangalore. And I described this theme in more details. For example, on the picture you see the hierarchy of different free monads and languages. For now, we just move further, okay? Good. Let's talk about the internal stuff, the interpreters. How would we test our business logic? how we would run it firstly. Yeah? To run it, we have an interpreter that just goes through the all business logic step by step and converts every step into a meaningful, effectful function. For example, run IO just evaluates the internal IO method. Log info, in here it just puts strings into the console, nothing more, but you can probably call some internal logger library here that is hidden from business logic. For example, colloc or tinylog. From the outside, you won't be knowing what is the library used, and you probably don't need to know that. But here in the interpreter, you call the native functions from different libraries. Or, for example, for the database, you can call native DB connect and even interpret the internal language via run database, the interpreter that is not presented here. Returning back to the question how we would test our business logic, we can implement an additional interpreter that will be going through your business logic with a certain purpose, not to evaluate it, but to try to see what happens there and to match with expectations. You know, this test interpreter is not really helpful because whenever it hits run IO or connect DB, it just throws an error. Not that impressive, right? We can't test that much logic with this interpreter. So we probably can improve it. How we can improve it? In unit testing, which is Whitebox testing, we want to see what results every step produces. And if we hit some external call, we don't want to call it actually. For example, we don't want to interact with the database in the unit test. Otherwise, it's not in a unit test, right? What we can do here, we can mock our step with a predefined value that we will keep in our test runtime. A special structure just for this only purpose. And this structure will be used only in tests. So no business logic doesn't know about this test runtime. Still, you can evaluate your business logic step by step, replacing every step, every effectful step by some predefined mock. This is how usually unit tests work in OOP languages. For example, you have mocked types, mocked values, you configure your tests, and these tests substitute the calls. And we can do the same in Haskeller. Okay? Do you follow me? This is how the test can look like. In particular, we call our test interpreter here with our flow, which is get students count flow, with some data passed there. It fails. Why it fails? How do you think? Why it fails?
Because we don't have any mocks?
Yes, it doesn't have any mocks. And when it doesn't have any mocks, it hits a step, tries to extract some mock, and there is no mocks, an empty list, and it just throws an error. How we can fix it? Okay, we can provide some mocks, for example, mock for connection or mock for student values. For each query, we had 2 queries, right? And therefore, we have a list of 2 lists for RunDB mocks. After that, our interpreter will go through the logic and will ask for the next mock for each of these runtime values, runtime in vars. Okay? Very simple. Except it's probably very tedious, right? Tests such this, because you need to understand what mocks you need to pass. You have to construct these mocks, you have to adjust your test so that different mocks match together and produce meaningful results, right? This is a flow of unit tests because they require a time to manage. But nevertheless, it's possible to use unit testing in Haskell. But if you try to Google unit tests, you will see that people really don't like unit tests. Who likes unit tests in here? Oh yeah, awesome. You guys awesome. Because I hate unit tests, and there is a reason why I hate it. But firstly, before we go why I hate these unit tests, let's try to search something else. And Google gives us a lot of pictures, which are called test pyramids. These pictures show how the tests can be organized, like what tests are more important, what tests are less important, and how they interact, what purposes they have. And there are a lot of such pyramids there, for example, like this pyramid. And you see the unit testing is on the bottom, like a foundation for testing. Yeah. I have no idea what is E2E. End-to-end. I have no idea what is end-to-end testing actually, but it's not important here. Maybe such pyramid, a lot more tests, functional tests, UAT, have no idea what is it. Okay, user acceptance tests. Good, good, good. System tests, yeah, integration tests. Maybe this is more informative pyramid, right? It allows you to ask questions. And even more pyramids for different kind of ideas. Yeah, looks pretty funny, I guess. One more pyramid. And here we have an additional information that we can automate our tests, right? And maybe the bottom tests starting from unit are pretty much solid, but the upper tests, top tests, too fragile to manage. Because, you know, when you have integration tests, they interact with a separate external subsystem, and this subsystem can fail. For example, database can be not available on the moment by some reason. So the integration tests are pretty fragile, and they can fail. But it seems unit tests shouldn't, right? One more pyramid, two more pyramids. This pyramid tells us that UI tests are slow and unit tests are fast, and also UI tests are more costly and unit tests are cheap. And this pyramid also stays the same. The unit tests are cheap. Do you agree unit tests are cheap? No? Okay. Unit tests are cheap. I don't agree with that. It's a lie. Because when you have a scenario, you write a unit test. It's a simple scenario that contains only one row, and unit test will be simple as well. But once you add new line to your scenario, unit tests are starting to grow in count and in length and in complexity, and it becomes even worse. Time passes, you have a very complex scenario and ridiculously complex tests for unit. And I believe the complexity of writing tests is like O n cubed, because you firstly need to write unit tests for all scenarios. Secondly, you need to write to adjust your unit tests for all types of calls in every scenario. And thirdly, you need to count all the edge cases happening in your scenario, and so you need to test those tiny things, and the complexity explodes, right? But what to do? How we can test our application without such pain? Is there a way? Excuse me? No? Just don't write tests. Very good advice. I like it. Unfortunately, I believe we can't proceed very fast and reliably without writing tests, because we need to be sure that our logic works, and we need to refactor this logic. Without tests is a nightmare. And what we can do to not to write tests but have them anyway, to have a cake and eat it as well. Let's talk about automatic white box testing, the technology for this talk. Take a look on the picture. In here you see the flow in the middle. Each step is there, and the player which tries to evaluate each step against a separately defined entry, recording entry. This recording entry is essentially a JSON representing some useful info for this step. If it was a unit test, then a recording entry could be a mock. But here it's another thing. It looks like this. It's a JSON file for a real flow that we seen before. It has 4 different entries here, for connect entry, for run-db entry, and for log info entry. Each of the steps contains useful info, and the player is able to pass through your business logic and to use these entries to compare what's happening. Essentially, this recording represents your business logic fixated in some form, like unit test does, but in form of JSON recordings. If you have this recording, you can do a lot of things with your tests. Okay? Let's elaborate this. The first idea is we can take this recording from every scenario that is built on top on the free monadic framework. And you don't need to adjust your scenario. You don't need to write any tests. You just run your scenario in a production environment with a predefined key option enabled, like to record the flow into the JSON. And voila, you have a JSON for every hit of your business logic, like some external service called your service. It evaluated the flow and recorded the flow as a recording. You don't need to do anything here. After that, you have a JSON file that you can pass to the player, and you can specify what flow you want to test. If the player sees that the recording matches the flow, then you are fine. The business logic didn't change, and there is nothing bad here. But if something differs from the business logic, you'll see a playback error with some meaningful error, and you can even see the step in which the error happened. And so, for example, you have a golden set of these JSON recordings. After some time, your flow changed, and you try to replay all these recordings, and you see immediately that the flow changed wrongly in this part, in this step, and in that step. And the results the flow produces are quite different, maybe wrong, possibly wrong. and you can assess what's happened. This is the general idea of this. And the next slides are about how we can do it. Okay? First of all, we have to create 3 runtime modes. Regular mode is like your flow, your scenario is evaluating as usual. Recording mode, it's evaluating as usual, but also it produces recordings for you. And replaying mode, when the recording is used for flow to mock something. After that, you need to adjust your interpreter. Again, business logic isn't touched. Business logic is the same. Even a free monadic language is the same, but the only thing you need to change is the interpreter. And here you see that we call our effectful evaluation like put strel line in some environment. With run mode is responsible for switching between those run modes, and there is an entry constructor that is corresponded to the step we are evaluating. For example, we need to generate log info entry. We can put there the information we need. We, for example, are interested in the message, and we store it in the entry. And this with run mode function does all the thing to either record your step or maybe evaluate this step. I won't present you the details of these internal functions like record, replay. You can see the implementation in the showcase project. Okay. Also, there are some things in the constraints like RR item. It's for internal machinery, and this is how it looks like. Essentially, you can add new steps into your business logic. You can extend your free monadic framework without breaking the things, but you have to define new entries for your new steps, okay? And this is how you can do this. Some type classes and some entries. What's important here, the entries should be serializable. Like you can convert them to JSON and from JSON, because each entry is essentially a mock for your step. This is why we need to serialize this data. There is a subtle question about what we can do with types that cannot be serialized, but we want to use them in our business logic. For example, how could you serialize a database connection? It's valid on the moment of script evaluation, right? Not on the moment of its replaying, because connection is not valid on that case. There are several answers to this question, and essentially you need to create your own types that are serializable and which carry your useful info and which can be translated into the internal types that are not serializable. After that, you will be able to record your business logic. So all the types used in the flow monad and returned and taken by the methods should be serializable. Okay? This was a short overview of the technology. Do you have some questions maybe? No? I believe it's not really impressive to have such recordings, because who doesn't do this, right? Maybe we can do more. Essentially, we can do more. We can unify unit testing and integration testing using this technology. We can use our mocks not only for mocking, but to do more things. Consider such a simple scenario, even more simple than we seen before. Just two strings that are printed to some log. And the corresponding recording, right? 2 entries here. And we have a playback error. Why? How do you think?
Because messages will have time.
Yeah. We have different messages in the step number 1 and in the flow. The player will check the info which provided by mock recording and the flow, and it sees that rows arrayed remove added bread is different from message number 2. This is a problem, like something is wrong. You probably need either to change your business logic, or maybe you can just edit your recording. It's possible, why not, right? Maybe you think that your business logic is fine. You wrote it to behave like this, but your recording is wrong. It's a normal situation. You have to be able to edit your recordings. We also can pass some configurations to the recording. For example, this configuration, this option, NoVerify, tells us that we should not compare the information stored in the entry with what's happening in the step. After this, the player will be succeeded because it doesn't matter what the additional info says. It just skips the verifying step. We also can say we don't want to mock these steps. We want a real effect to be happen, like print me that string, and it does. It uses the recording to evaluate the steps. It matches the steps and the flows, but doesn't do anything more. So this is how you can do external calls with the recording. You can place NoMock for every entry you have in the recording, or those you need to. For example, calling external services via HTTP or calling database, you can place NoMock there, and external service will be called. This mixing mocking and no-mocking steps gives us effectually integrational testing, right? There are even more different configurations to this system. For example, we can configure our recorder to skip some entries. They won't appear in the recording at all. Maybe useful, maybe not. For such recording entry, for each recording entry, you can configure to verify it or to mock it, or don't do this. And you even can configure your player to skip some entries, to disable mocking for some classes of entries, and to disable verification for some classes of entries. You can finally tune your testing environment to achieve the results you need for different use cases. When you don't have tests, but you are able to produce testing data and to store this testing data for further usage, it becomes really cheap to maintain such tests, because all you need to edit, to read your recordings to see whether they fine, whether they valid, maybe tune something them, and you don't need to write a lot of tests. You don't need to write a single line of test. And yeah, integration testing for free. Yeah.
What does class mean?
It's like
Here,
here the word class means that you can disable all log entries in a wall replaying process, or you can disable all RunDB entries by a single configuration. It's like a class of entries, log entries.
it corresponds to a single constructor of your initial
Yes.
function.
Yeah, right. And here we go. Conclusions. How to pronounce it? When you have such a free monadic framework, each scenario you write will be testable by default. I believe it's cool because you don't need to spend much efforts to support testing infrastructure. And this, I believe this technology proves that free monads are worth to learn and to use. And we are happy with this technology. And probably we can invent even more ideas how to improve this technology. You can, for example, take performance analysis, performance evaluations for each step and write them into the recording and match whether the step started evaluating too slow. You can enhance your automatic white box testing by another features. And probably this is all I wanted to tell you, except maybe this list of resources. First of all is the showcase project. I work in prototype for this technology. The next is the talk from Bangalore and support my book. There are several folks here who is supporting this book already. Thank you guys, you are awesome. And more projects that are based on my ideas of hierarchical free monads. And finally, maybe it's worth to check out this list for software design in Haskell. It's a lot of resources there, practically oriented for how to build our real applications in Haskell. Okay? And thank you for your attention.